Warm greetings to the gentlemen and ladies sitting over there and watching this video. This is Deepika. Happy to welcome you all to PRITHYA CLASSROOM. So let's get started with today's video. Today we're going to see Aptitude series, and in the last lecture we have seen what are the important facts and formula that we have to remember in order to solve Surds and Indices problem. And today we're going to continue with the same topic but with different kind of problems that we could expect out of this topic. Okay, so without delaying, let's get started. Okay, so hope you all remember all the identities and all the formulas that we have discussed in the last class on indices as well as on the surds. If not, please go through the topics before we proceed with the today's topic. Okay, yeah. So this is the first problem for the class 0.00032 to the power 3 over 5. So this is the first problem that we are going to see for today's class. Okay, so if you carefully look at this problem, here we have a power which is a fraction. So whenever you face or whenever you come across these kind of problems, there is a hint. Okay, there is a hidden hint. We could say like that because the hint is not direct but it is indirect. Okay, so you have to look at the denominator of the fraction, and the denominator of this particular fraction is 5. So they're trying to tell you you could convert the term that you have inside the round brackets into a term to the power 5 or multiples of 5. Okay, so this is the hint provided to us, and we're going to use that hint to solve this problem in a much more easier way. Okay, so first of all, whenever you have a number like 0.00 or 0 point something, try to convert them into a fraction like 32 divided by 1 followed by number of decimal digits. So here we have 1, 2, 3, 4 and 5. So I'm going to add 5 zeros. Okay, so now to the power 3 over 5. Okay, so we got the term, right? So now we are supposed to convert this particular term into something to the power 5. Okay, so let's start doing that. And we already know that 32 is nothing but 2 to the power 5, right? Okay, so if you're not sure, what you can do is you can go with the L division method that we have discussed in the last class to find how you can represent something as power of something. Okay, so now 2 to the power 5 divided by, and we all know that 1 followed by number of zeros can be represented by 10 to the power number of zeros. So here we have 5 zeros, so of course you can write it as 10 to the power 5. And if you carefully observe the term, we have numerator also, and denominator and numerator has power as 5. So you could take the power as common and you can write it as 2 divided by 5, sorry, 2 divided by 10 to the power 5. And of course you have some outer power which is 3 over 5. Okay, so this is what we have got right now, and we all know very well that a to the power m whole power n can be written as a m n. Okay, so now we are going to use this identity here, and what we can do, we can just multiply the inside power and outside power like 2 over 10 to the power 5 multiplied by 3 over 5. So when we cancel 5 and 5, we will get the numerator as a single number. Instead of fraction, we have got a whole number now, and our job is quite easy when we have a whole number, right? And if you carefully observe, we have a fraction which can be simplified further, right? Because 2 over 10, both are multiples of 10, sorry, multiples of 2, so you can write it as 1 by 5 the whole cube. And now it's very easy, right? So 1 over 5 whole cube is nothing but 1 over 125. And if you want to represent it in decimal format, it is nothing but 0 point, see 1 over 5 can be written as 0 point, okay, so let's do it in the new page. Okay, so 1 over 5 can be written as 0.2, right? So 1 over 5, the whole cube can be written as 0.2 the whole cube. 2 cube is nothing but 8. And when you multiply zero point 0.2 for 3 times, in total we have 3 decimal points, right? 1, 2, 3. So we have 3 decimal points. So what you can do, you have to make sure that in the answer you have 3 decimal places. 1, 2, 3. Okay, so the final answer is 0.008. So sometimes you might get an option in which they would have represented the final answer in decimal format, and sometimes you will have the answer in fraction format. Make sure that you are prepared for any kind of solution that they require or that they would ask for. Okay, so let's see the next problem. And the next problem, we're going to see again one more different kind of problem, I could say, because here the power is going to take a different format. We have seen whole number powers, fraction powers, and now we are about to see a number which is going to have a decimal power. Yes, a decimal number as its power, 0.16 multiplied by 16, 0.18, and highly it is impossible for us to figure out what would be the final answer if we have some decimal number in the numerator, but do not worry, we have some hint provided here. Okay, so whenever you have these kind of problems, you will have a hint, like you have to use this identity. A to the power m multiplied by a to the power n will be equal to a to the power m plus n. Okay, so this is the hint provided to you. So if you want to use this identity, first of all you should make the base as same. Okay, the base number as same. Here we have 256, here we have 16. Is there any relation in between 256 and 16? Yes, of course. 16 square is 256, right? And one more thing, in order to solve these kind of problems, make sure that you know the square of numbers from 1 to 20 at least, and cube of 1, cube numbers from 1 to 10, and it is well and good if you could remember up to 20 as well. Okay, so we know now very well that 16, sorry, 256 can be written as 16 square. So I'm writing 16 square to the power 0.16 multiplied by 16 to the power 0.18. Okay, so this is what we have got right now. So now here we can use one more identity. What is that? Yes, so we have inside one power, outside one power. So basically you could multiply them. So 2 times 0.16 will be 0.32 multiplied by 16 to the power 0.18. So now we have got a format. See, this looks exactly same as that of a to the power m multiplied by a to the power en. So what you can do here, you could write the answer as 16 to the power 0.82 plus 0.18. Okay, I'm sorry, it is not 8, it is 3. I myself got confused with my own handwriting. I'm sorry. Okay, so it is 0.32. And one more thing, this could happen in exam as well. Okay, whenever you're writing, make sure number is very clear. Okay, so now you will get 16 to the power 0.50. Okay, so now here, here again, you can do one more thing. What is 0.5? How you could represent 0.5 as a fraction? It is half, right? Even if you could not figure out directly, you can follow one method. 0.5 can be written as 5 divided by 10, right? So 5 by 10 can be simplified as 1 over 2. Okay, so what I can do here, I could write 1 over 2. So 16 1 over 2 can be written as square root of 16, and which is nothing but 4. Okay, so here we have got the final answer as 4. Okay, so let's move on for the next problem. Are you all coming along with me? Are you feeling bored? No, right? Aptitude is an interesting one. You will not feel bored. But of course, sometimes you will feel very complicated, but it is not. Okay, okay, let's continue. 2 to the power x minus 1 plus 2 to the power x plus 1 equals 1280. So here, see, you have got a very different problem now. It's something like equation, and here you want to solve for x. Okay, so whenever you have these kinds of problems, don't be panic. It's very simple and easy. Okay, so let me tell you how to proceed with these kind of problems. Okay, so now, you're going here, you have to use inverse of something. Like you already know that a to the power m multiplied by a to the power n can be written as a to the power m plus en. And here it is like inverse of it. You have a to the power m plus en, and you are going to represent it in multiplication of separate, so multiplication of base with powers individually. Why? Because when you do like that, you will get some common term in between 2x minus 1 and 2x plus 1. Okay, so let's see how we can proceed with these kind of problems. So you could write 2 to the power x into 2 to the power minus 1, then plus 2 to the power x into 2 to the power 1. Okay, so this is how you could write, and which is equal to 1280. Okay, so now in the next step, if you see 2x and 2x is common, so when you have 2x and 2x is common, you could take it out and you could write 2 to the power minus 1 plus 2 is equal to 1280. Today my handwriting is not good. Why? Because I'm using a different digital pen today, so I'm not used to it. I'm really sorry for that. Okay, so 2 to the power x and 2 to the power minus 1 can be written as 1 over 2 plus 2 can be written as 2, which is equal to 1280. Okay, so under the next step, what we are going to do, we're going to simplify them. Okay, so half plus 1 by 2 is nothing but 3 by 2 is equal to 1280. Okay, so we have got some number like this, and of course you can simplify it further as well. Okay, let's take a new page. We have got 2 to the power x multiplied by 5 over 2 is equal to 1280, right? So now what we are going to do, we are going to take this term to the other side. So we will get 1280 multiplied by 2 divided by 5, and you could cancel them, and you will get 2 times 5 and 6. And now see, 2 to the power x, 2 power x is equal to 256 multiplied by 2. And we all know very well that 256 can be written as 2 to the power 8. And if you could not tell it directly, no worries, go and do the division method and you could figure out. Okay, so now we have got 2 to the power 8 multiplied by 2, which indirectly means this 2 has 1 as its power. So, and we all very know very well, whenever we have a product of two numbers with same base and different powers, you need to sum the powers. 8 plus 1 is 9, and on the LHS you have 2 to the power x. So it is clearly visible that the value of x is 9. Very good, you're all clever students. So we have got the value of x as 9. Okay, so now let's move on for the next question. Okay, so fourth problem. Mm. 5 multiplied by 8 to the power 1 over 3, 27 over 1 over 3 whole cube 1 over 4. So when you look at this problem roughly, this seems very, very complicated, but when you look at it in deeper, it is not that complicated as it looks. Okay, so whenever you have double brackets, you need to solve the inner bracket first. That we all know very well. I don't think that I need to explain it to you because we all aware of Bodmer's rule, right? Good. So now let's solve the inner bracket first. So what does 8 to the power 1 by 3 means? 8 to the power 1 by 3 is nothing but the cube root of 8. So cube root of 8 is 2. What is cube root of 27? 3. That's all. So to the power 3 and whole power 1 over 4. And next the step. So now 5 multiplied by, what is 2 plus 3? Just 5 again. To the power 3 and to the power 1 over 4. Right. So now if you look here, we have two numbers and multiplications with same power, sorry, same base and different powers. So you have to add up the powers. So it is 5 over 3 plus 1, which is 4 to the power 1 over 4. So here we have inner power, outer power. So what do you need to do? Yes, very good. You need to find the product of powers. What is 4 into 1 over 4? Is 1, right? So 5 is the answer. See, this problem looked very, very complicated in the beginning, but you could see we got the answer in 3 or 4 steps, right? Good. And when you practice more such problems, you can do it even without these many steps. On looking at the problem itself, you'll just put like this. Okay, this is 2. Okay, this is 3. So 2 plus 3 is 5. So we have 5 cube 5. So finally you'll get 5 over 4. So already we have 1 over 4 on the outside. So when you multiply, we'll go to 5. You could do all those mind calculations in your own time. Okay, but it needs practice and patience. Okay, so that's all for the today's class. In the next class, I'm going to take 2 or 3 more problems to tell you the different kind of problems that you could expect out of this topic. Yes, we have variety of problems that could arrive in this particular topic. So be patient with me. I'm taking more than 3 videos. I'm taking more than one video. Like totally, we have 3 videos, right? Okay. Thanks for watching this video. If you think you have learned something from this video, consider subscribing the channel and share it with your friends and family so that I can reach as many people as I am dreaming of now. Thank you.